Hey scholars, I hope y'all are doing great today. For this lesson, we are going to talk about this thing called the unit circle. It may seem like a little bit of a doozy, but just stick with me. It's going to get a lot easier. But I'm just going to talk about how to develop the unit circle, where it comes from. So just try to follow along with me, and then I promise things will get simpler. But go ahead and make sure you're ready to take good notes. Let's get going. Probably looking at this a little confused. Why are we talking about special right triangles? I thought Mr. Pittner said we were talking about the unit circle. Well, the unit circle actually comes from special right triangles. I know you're super excited about that because you remember that from geometry last year. But we are going to use special right triangles, the 45-45-90 triangle and the 30-60-90 triangle, to help us actually develop the unit circle. So let's just do a quick review of a 45-45-90 triangle. All right, so for a 45-45-90 triangle, which we can also call an isosceles right triangle, the two legs of that triangle are going to be congruent, okay? So let's just say each of these was 2 units long. So whatever the lengths of the legs are, those congruent legs, we would take that and multiply it by the square root of 2 to get to the length of the hypotenuse. So we would say 2 times the square root of 2. Okay? So if the leg lengths are 2, then the length of the hypotenuse is 2 times the square root of 2 units. So let's look at it from this perspective as well. Let's say the length of the hypotenuse was, let's just say it was 2. Okay? Well, how do I get to find the length of the legs? How do I find the length of the legs? Well, I'm going to take 2, and because the hypotenuse is the length of the leg times the square root of 2, I'm going to take 2 and divide it by the square root of 2 to get the leg lengths. Okay? But here's the deal. The problem is I have a radical in my denominator when I divide by the square root of 2. So what I'm going to do is I'm going to rationalize, and I'm going to multiply by the square root of 2 in the numerator and the denominator. Hopefully this step looks familiar. Remember, I'm not changing the value of this number here. This value here is 1. Okay, so square root of 2 divided by square root of 2, that's 1. It's just like I'm saying 2 divided by square root of 2 times 1. So 2 times square root of 2 is 2 times square root of 2. And square root of 2 times the square root of 2 is just going to give us 2. So then 2 divided by 2, those are just going to cancel. And then we're left with the square root of 2. So the lengths of the legs are going to be the square root of 2. Okay? So that's how we use those rules for 45-45-90 triangles. Let's talk about the 30-60-90 triangle. So you have the 2 legs. One is the short leg. Here's the short leg, and then you have the long leg, and then you have the hypotenuse. Well, if you know the length of the short leg, let's just say it's 2. To get the hypotenuse, all you do is say 2 times the short leg. So that's going to give us 4. Well then, to get the long leg, you can say 2 times the square root of 3. Well, that's just 2 times the square root of 3. So if the short leg is 2, then the hypotenuse would be 4. The long leg would be 2 times the square root of 3. That's how we use those special right triangles. These are what we call the reference triangles for 45-45-90 and 30-60-90, and they're going to help us develop the unit circle. So I just wanted to provide a brief review of those real quick. Let's talk about what the unit circle actually is. So the unit circle is a circle drawn around a coordinate plane with a radius of 1 unit. So here you see the unit circle. It's on the coordinate plane. It has a radius of 1 unit. So you can see it labeled there. Here's that radius. Also, here are some other radii. And remember, the radius is just always the distance from the center of the circle to any point on the circle. It just goes from the center to any point on that circle. Now, we can see these radii fall along the x and y axes. Okay? So this point right here, we have gone 1 unit over on the x-axis. So the x value is going to be 1 and the y value is 0 because it lies on the x-axis. Similarly, when we look at the y-axis here, we've gone up 1 in the y direction, right? And we have not gone to the left or right from the center. So the x value is going to be 0, the y value is going to be 1. And then you can see us going in the negative direction on the x-axis. This point is -1, 0. The negative direction in the y-axis. This point is 0, -1. Okay, so these are some special points that fall on our unit circle. The radius, like I said, is 1. So theta means an angle, right? That's going to be an angle measure. So the cosine of theta is just going to be the x value. Let's see why that is. The cosine of any angle is the adjacent side over the hypotenuse. Well, check this out. Let's look at this right here. Let's see how it makes a right triangle. So we've got a right triangle right here. And then here we've got theta. You can see theta right there. I've kind of covered it up with the pen there. But we got theta. So adjacent, here would be adjacent. And here's the hypotenuse. So the hypotenuse is always going to be 1, right? And this adjacent side is the x value, right? So you can see that the adjacent side is the x value here. And so we're going to say the cosine is the adjacent side is always the x value, and the hypotenuse is always going to be 1. So the cosine of theta is x divided by 1. So the cosine of theta equals x. Similarly, sine of theta is opposite over hypotenuse. So the sine of theta, well, check this out. The opposite side of this triangle goes up and down, doesn't it? The adjacent went left to right, like the x-axis does, right? The opposite goes up and down like the y-axis. So we've got the opposite side is the y value. And remember, the hypotenuse is 1. So the sine of theta is the y value. Okay? And then check this out. So it's tangent theta equals y divided by x. Let's figure that one out. Well, tangent of theta is opposite over adjacent, right? Well, opposite is the y value, and the adjacent is the x value. So tangent of theta is y over x. Okay? Now, so we can write the coordinates of any point. That's what it means by p. Any point can be written as the cosine of theta, comma, the sine of theta, because the cosine of theta is the x value and the sine of theta is the y value. So those are just some ground rules that we need to establish before we start developing this unit circle. If it feels a little overwhelming right now, that's okay. That's good. Your brain is stretching, okay? It's going to keep stretching. Just follow along with me here as we now develop the unit. Now, before I start developing this out, I just want to encourage you to look at your slides. If anything on here looks blurry at all, look at your slides. All right, so now let's talk about how to develop the unit circle, where it comes from. So all these lines here that you see inside this unit circle, they refer to special angles that we're going to learn about, okay? So we're going to have like different angles that we'll be learning. Like this is going to be a 30-degree angle, okay? This will be a 45-degree angle here. This angle right here formed by this line and the x-axis, that's a 30-degree angle. And then we have a 60-degree angle there, okay? So we are going to find the point values at each of those angles, okay? Now, when I give you an actual handout of the unit circle, you will also see radian measures on here. So like for example, 30 degrees is pi divided by 6. 45 degrees is pi divided by 4. 60 degrees is pi divided by 3. Okay? So, you'll see that on there. You already know how to convert between degrees and radians, so that shouldn't be something that's terribly confusing for you. Now let's find all these point values that I just mentioned. Okay? We're going to use special right triangles to do that, and we're also going to use rules of reflection that you learned about in geometry last year as well. Okay, so let's go ahead and get underway. So let's start off right here. We're going to say this is a 0 degree angle. All right, so here we've got our terminal side just falls along our x-axis, so it hasn't moved at all. It hasn't started going around the circle yet at all. So we'll say it's a 0 degree angle. And so the radian measure would just be 0 as well. Okay, so we know the radius of the circle is 1, and we've gone 1 over on the x-axis. So this point value is just going to be 1 in the x direction and 0 in the y direction, like we talked about earlier. You actually just saw that on the last slide we were on. Okay, and so while we're at it, let's find these values as well. We just talked about them. We're going up 1 in the y direction, and then just 0 in the x direction. So 0, 1, and then this point is going to be negative 1 in the x direction, and then 0 in the y direction. And this point is going to be 0, negative 1. Okay. And so for each of these quadrants, here we got the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? For each of these quadrants that you go over, we're going over 90 degrees like we've talked about before. So the angle measure here is going to be 90 degrees, which is pi over 2. Okay? Go over another 90 degrees. This is going to be, 180 degrees. We've gone 180 degrees clockwise, and that's just pi radians, right? So we've got 90 degrees is pi over 2 radians, and pi radians is 180 degrees. So in the third quadrant, we've gone 270 degrees, and that is 3 pi over 2 radians. And then go 360 degrees, so all the way back around, that is 2 pi radian. So we have found the angle measures, we have found the radian measures, so we found it in degrees and radians, and then we found the coordinates of those as well. Okay, so we're going to do that for all these other angles. Okay, so check this out. Follow along with me here. This is where it starts to get a bit tricky. So we've got a 30 degree angle right here. Okay, so we got 30 degrees right here, and then what I'm going to do is I'm just going to drop down a vertical component right here, and that's going to give us a triangle. It's going to give us a right triangle. So now what we're going to have here is a 30-60 right here, 30-60, 90, because we got a right angle right here, right? 30-60, 90 right triangle. All right, so now I know that this is the short leg. I know this is the long leg. I know this is the hypotenuse. Remember, the hypotenuse is always going to be 1 unit. Okay, so this hypotenuse is 1 unit. So I want to find the x and y values of this coordinate point. Okay, so here's what I'm going to do. I'm going to use the 30-60 triangle to figure this out. Well, to get from the hypotenuse to the short leg, remember, the hypotenuse is 2 times the length of the short leg. So I'm going to take that and I'm going to say 1 divided by 2. And I'm just going to leave that as 1/2. So that's going to give me the short leg, which is the y value. So the y value is 1/2. All right. So now that I have the short leg, I want to get to the long leg. The long leg is going to give us the x value. Okay? It's going to give us that x value. Well, I'm going to take the short leg and multiply it times the square root of 3. So 1/2 times the square root of 3. And that's going to give me the square root of 3 over 2. So the x value is going to be the square root of 3. I'm going to write it like this. I'm going to say 1 over 2. And then the x value is square root of 3 over 2. So the x value is square root of 3 over 2, and the y value is 1/2. Now, check this out. This is going to help us get the rest of the circle really easily, okay? So if I reflect this across the y-axis, when I reflect across the y-axis, remember the sign of the x value is going to change. So I'm going to reflect this across the y-axis, and that makes the x value change sign. So I'm going to have negative square root of 3 over 2, comma, and then the y value stays the same, so it's going to stay 1/2. So square root of 3 over 2, negative square root of 3 over 2, comma, 1/2. That's going to be the coordinates over here. Now, I'm 30 degrees away from the 180 degree measure over here, right, on the x-axis. So that's actually going to mean that this is a 150 degree angle right here. 180 minus 30 degrees, right? 30 more degrees. 150 plus 30 is 180. So that's going to be 150 degrees. And then in radians, that is going to be 5 pi over 6. 5 pi over 6 radians. All right. So I can do that for the rest of these angles as well. I'm going to reflect this angle across the x-axis. When I reflect across the x-axis, the y value is going to change signs. So the x value will stay the same. It'll be negative square root of 3 over 2. And then 1/2 is going to change to negative 1/2. So negative 1/2. All right, and so that is actually, I've gone 30 more degrees in this direction, haven't I? So that's going to be a 210 degree angle. And in radians, that is 7 pi over 6 radians. I'm going to do one more reflection across the y-axis. Reflect this across the y-axis. That's going to make the x value change signs again, isn't it? Okay, so that's going to give us this 330 degree angle. All right, reflected across the y-axis, 330 degree angle. So that's going to give us 11 pi over 6. That's going to be its measure in radians, 11 pi over 6. And so when we reflect over the y-axis, the x value is going to change signs. So we'll have square root of 3 over 2. So we're back to square root of 3 over 2, aren't we? See how the x value is positive on this side? But the y value is negative in the fourth quadrant, right? So the negative y value has stayed the same when we reflected it. So negative 1 over 2. All right. So we found some angles on this. We found the 30 degree angle, the 150 degree angle, 210 degree angle, and the 330 degree angle. All right. Now, this might start to look a little bit messy, but follow along with me here. Since we just talked about 30, 60, 90, let's stay on that track. We'll look at the 60 degree angle, then we'll deal with the 45 degree angle. So, now, we're looking at the 60 degree angle. If I drop a little side right there and make a right triangle, then remember that radius is still going to be 1. That's the hypotenuse, right? Well, the x value is the short side now, right? So that's going to give us 1/2 because we just take the hypotenuse and divide by 2. So that's going to be 1/2 in the x value. And then similarly to what we did earlier, the y value in this case is going to be square root of 3 over 2. I'm not going to go through that process again. But just compare it to the 30 degree angle. Okay? We had square root of 3 over 2, comma 1/2. Here we have 1/2, comma square root of 3 over 2. Okay? So they just switch between the 60 and 30, as you can see there. Okay? All right, now let's apply our reflection rules. Reflect across the y-axis, that's going to get me to this point right here. So across the y-axis, that's going to change the sign of the x. It's going to be negative 1 over 2, comma, square root of 3 over 2. Okay? So those are our coordinate points there. And then that angle was, well, we're 30 degrees away from 90 right here, right? So we're going to be 30 degrees away from 90 on this side. That's going to give us a 120 degree angle. And then this will give us, that's going to be 2 pi over 3. Let's say 2 pi over 3 in radians. Okay? 2 pi over 3 radians. All right. And so let's keep going. I'm going to reflect across the x-axis now, changing the y value. That's going to give us, this will be a 240 degree angle. And in radians, that's going to be 4 pi over 3 radians. All right, and so the coordinate point, we're reflecting across the x-axis, so that's going to change the y value. We'll have negative 1 over 2, square root of 3 over 2. Okay, so then I reflect across the y-axis, and that's going to give us to this 300 degree angle. And so that's going to be 5 pi over 4 in radians. And when we reflect across the y-axis, the x value changes sign, so it's going to go back from negative to positive. So positive 1/2, and then we still have negative square root of 3 over 2 here. So it is positive 1/2, comma, negative square root of 3 over 2. Now, we've gotten all the 30 and 60 points. Let's finish this out by doing the 45, okay? Now it's going to be a little bit different here, but I'm going to drop right here, and that's going to give us a right angle. We know that this hypotenuse is going to be 1 unit long, right? So now let's look at the 45, 45, 90 triangle. Well, the hypotenuse is 1, right? Well, like I mentioned earlier, to get the legs of that triangle, we need to take the hypotenuse and divide by the square root of 2. But we cannot leave that radical in the denominator. You've got to rationalize. So I'm going to multiply by the square root of 2 over the square root of 2. And that's going to give us the square root of 2 over 2. So that's going to be the case for both the x value and the y value. They're both going to be the square root of 2 over 2. So we get the square root of 2 over 2 for the x and y values for 45 degree angle. So let's keep going over here. We're going to reflect across the y-axis, and 45 degrees away from 90 degrees, that's going to give us 135 degrees. And that is a radian measure of 3 pi over 4. And so then that coordinate point, when we reflect across the y, the x value changes, so we get negative square root of 2 over 2. And then the y value stays the same, square root of 2 over 2. And remember, this should make sense. The x values in this quadrant should all be negative. The y value is positive. Negative x, positive y. Okay? So that works. All right, so now I'm going to reflect that 135 degree angle, those coordinate points, across the x-axis. That'll change the sign of the y value. So both of them are going to be negative. So negative square root of 2 over 2. Negative square root of 2 over 2. Okay, those will be our coordinate points there. All right, and then that gives us a 225 degree angle, which is 5 pi over 4. All right, last one. We only have one more left. I know it looks a little messy, but let's keep going, finish it out. All right, so reflect that across the y-axis. That's going to change the sign of the x here when we reflect across the y. So the x value is going to become positive. It's going to change from negative to positive. So we get square root of 2 over 2. The y value staying negative. Negative square root of 2 over 2. So those are the coordinates there, okay? And that was for a 315 degree angle, which is 7 pi over 4 radians. Voila! We have now developed the unit circle. Take a deep sigh of relief. Good job. The circle. So I know that video was long, but take a sigh of relief because you will not have to do everything I just did. I wanted you to see where it comes from because the unit circle is very important, but you will just need to be able to reproduce the unit circle, not develop it all out. So make sure you're familiar with it. We're going to use it a lot over the next few weeks, but just come to class prepared to learn and work hard. Good work today. Thank you, collegiate scholars.